Okay. Oh, what time do we get out of here today? 11? Oh, we're good. Okay. All right, so 7.2 was hypothesis testing for a mean when we know the population standard deviation, which means we use Z. 7.3 is still hypothesis testing for means. We're going to see a lot of similar things in this lesson, but this time we don't know the population standard deviation. Instead, it's going to be a sample standard deviation, and if you remember, that's when we use our t-charts for this lesson. So a couple things we need to talk about because we're going to be finding critical values and using those rejection regions again. When we do the critical values, you're going to have a specific level of significance that's going to be given to you most of the time. Remember, with our t-chart, we use degrees of freedom. So if our sample size is n, degrees of freedom is always n minus 1. Then, if you look at your t-chart, you guys have it in front of you, when we used it in the past, we used the top row, which was level of confidence. We use that for confidence intervals. The two rows right below that have one tail alpha and then two tail alpha. So you need to know when you're looking at your chart if it's a one tail or a two tail test. So if it's a one tail, that could be a left tail or a right tail. You're going to use that row. And if it's two tail, you use that row. Then you go over to whatever your specified level of significance is in that row. You go down to your degrees of freedom and you find the value. If it's a left tail test, your t-value should be negative. If it's a right tail test, your t-value should be positive. If it's a two-tail test, you should have 1 plus, 1 minus. And you can actually see that on the side of your t-chart. It gives you little pictures of what a left tail looks like and has a little negative t there. Right tail, it has just a t, and then two-tail has a plus and minus t. The chart itself only has positive values, so you need to know to put those negatives in when it's appropriate. So if it's a left tail test, we make it negative. If it's a two-tail test, we put a plus or minus in front of it. This is going to be the one instance where right tail test is actually less work, because the right tail test, we want the positive t, and that's exactly what we have. All right, so we're going to do these three. Just practice finding that critical value. All right, find the critical value. Our book uses t sub 0. If you use t sub c, I'm okay with that too. For a left tail test with a level significance of 0.05, and an n of 21. So if n is 21, what's my degrees of freedom? 20. Okay, so left tail means one tail test. So find one tail test at the top, go over to 0.05, go down to 20. One tail, 0.05, so I'm in the second column, down to 20, 1.725. And then you just need to remember, because it's a left tail test, we make that negative. And when we sketch it, it'll be on the left side of our standard normal curve, or our curve in this case. All right, next one, right tail test. Level of significance is 0.01. N is 17, so degrees of freedom is one less than that, 16. All right, so again, right tail, we're still at a one tail test. Level of significance, 0.01. We're going to go down to 16. 2.583. That's a right tail test, so it remains positive. Okay, critical values, and it's telling us plus and minus here for a two tail test. Level of significance 0.1. N is 26. If n is 26, my degrees of freedom is 25. Two tail test and 0.1. All right, so find two tail tests at the top. Go over to 0.1. So we're in the second column again, down to 25, 1.708. And then because it's a two-tail test, we're putting plus or minus in front of that. Do you guys remember what to do if your degrees of freedom isn't listed on this chart? Like if my degrees of freedom was 62, what would I use? Remember, go up or go down. If my degrees of freedom was 62, that's not listed on here. Down. Well, technically on the chart, you're going up, but you're going to the smaller degree of freedom. So if it's 62, maybe make a note to self because you might have those pop up. If it's 62, I would use 60 degrees of freedom. Okay, so we always round it down to the next one that we can find on our chart if it's not listed. Most of the ones you have will be listed though. Okay, does that make sense? on getting these critical values? Do we need to practice that, or are we okay? Are we okay? All right, skip the next slide. We don't gotta do it. Moving on. You need your calculators now. Okay, so there's two types of hypothesis testing we can do. We can use the p-value that we've done before, or we can use rejection regions. P-values are pretty difficult to find just with a t-chart. It gets a little more complicated, so we only use technology if you're doing the hypothesis test with a p-value, if it's our t-test, okay? With the z-chart, we could do it. It was a little easier to find those areas we were looking for, but if it's a t-test, and it's a p-value, we're only going to use technology. All right, so an example, Department of Motor Vehicles office claims that the mean wait time is less than 14 minutes. A random sample of 10 people has a mean wait time of 13 minutes with a standard deviation of 3.5 minutes. At a level of significance of 0.1, test the office's claim, assume the population is normally distributed. Okay, so I'm normally distributed, check, I'm good there. As soon as I see that my standard deviation is a sample, I know I'm using t now. This is not going to be a z-chart, okay? So that standard deviation is going to tell you the difference between the two tests, and it's going to make a pretty big difference sometimes in your answers, so you want to make sure you look for that first. Even though we don't need it for the calculator, I think it's going to be helpful to write down at least what your null and your alternative hypothesis are, because we're going to refer back to those for a couple things we need to put in the calculator. The mean wait time is what we're claiming about. Everything still is about a mean, is less than 14 minutes. So is that a null or alternative hypothesis? It's an alternative hypothesis. Mean less than 14, mark it as your claim. Is that for me or somebody else? All right, Aiden and Matt. If the alternative is less than, what's the null? The mean is greater than or equal to 14. Okay, things that we're going to put in the calculator, and we'll get to the actual menu in a second. You need, you can see the mu sub 0 there. That number, remember, is what we see in our hypothesis. It's whatever the claim is being made about. So in this case, it's going to be 14. My x bar is my sample mean. The sample mean was 13 in this problem. And now our standard deviation, we're going to see the S for sample instead of the little sigma for population. Standard deviation was 3.5. My N, my sample size, is 10. And then can you guys tell me, is this a left tail, right tail, or two-tail test? This is a left tail because of that alternative hypothesis. So the option that you're going to choose down here, it's the one that's less than is the one that we're going to pick. Remember, you've got 3 of them that you can highlight. Okay, so in the calculator, this is really similar to what we did with the Z's before. You're going to go to Stat. You're going to go over to Test, and then you have to know if it's Z or T. Again, that's all to do with the standard deviation. It's a sample, so we use T, number 2. And then you can input this information. Now, I do want to show you guys, when you get to Math Excel, they might not outright give you that sample mean or give you that standard deviation. If you go over to Data and hit Enter, you don't have to enter the standard deviation and the mean. It instead uses whatever values you have in list 1. So instead of actually calculating it and then using it, you can just put all that data in L1 and then use this instead. And the only thing it's going to ask you for is that first number that is in your claim. And then if it's a left tail, right tail, or two-tail test. Where it says frequency there, that's just how many times we use each data value in the list. So just keep that at 1 because every data value is used once in most cases. All right, we have the stats. We don't have the raw data, so that's why we're using the stat option here. And then go ahead and put all this in there. Again, we're going to highlight the one that's less than. I wrote mine wrong, I guess. Make it match there. It was less than, it looks like that. Okay. All right. And then hit calculate when you're ready. Okay, so it gives us a few things. It gives us a critical value of t. And with technology, we get a lot more decimal places, which is nice. It's a lot better than what we would get on our chart. But the p-value is what's ultimately going to make the decision for us. So before, same thing, we compare p to alpha. P is 0.195, if I give it 3 decimal places. Alpha in this problem is 0.10. So in this problem, P is greater than alpha. So if P is greater than alpha, do you remember what we do? Fail to reject. Do not reject. And then you can summarize that too if you want to. You could say there is not enough evidence to support the claim. So is not, because we did not reject, and support, because my alternative hypothesis was the claim. If it said in context of the problem, I would just be a little more lengthy with that explanation. I would say there is not enough evidence to support the claim that the Department of Motor Vehicles office has a mean wait time of less than 14 minutes. Okay. Any questions? All right, the next two are yours to try, and we're going to put answers up on the board. It tells us at the top, we're assuming the population is normally distributed, so our conditions to be able to do this are met. I'll give you a few minutes. Answers.
Stop.
Stop. What questions do you have getting the p-value, making our decisions, summarizing? Stop. Do you want to move up here?
No.
Get away from it? All right. No questions? We're good on this?
Yeah.
All right. Last slide is quick. On Monday, we're going to do rejection regions and the full-blown hypothesis test like we did with the z-scores. So this is just extra little practice with, based on the t-value that we have, if it's in the rejection region, we reject. If it's not in the rejection region, we don't. So for that first one, I have a right tail test. My critical value is 1.402. If I calculate a t-value of 1.4, would I reject or not? If my t-value is 1.4, is that in the shaded region?
No.
It is not. So what does that mean? Yep. Do not reject. Okay. What about 1.42? Reject. What about negative 1.402? Do not reject. What about, on the other one, I've got a two-tail test, it looks like, critical values plus and minus 1.725. So if I have a negative 1.755, would I reject? What about negative 1.585? Do not reject. What about 1.745? Reject. All right, 2 Math Excels are all due tonight, whatever you haven't finished from those. There are only two 7-3 Math Excels, because we did half of it today, half of it on Monday. Honestly, you guys could probably do all of it because it's so similar to the Z one. We just calculated t-value instead. So if you want to get ahead, this is a good lesson to do that, but we'll finish up 7-3 on Monday. And those 2 Math Excels are due on Tuesday. So Friday, Tuesday are your 2 deadlines that are coming up. Okay?